Hello, this video is Cramer's rule and it focuses on applying determinant to solve systems of equations. I repeat, systems of equations. Very good. And we are concentrating on 2 by 2 metrics. Let's have a quick revision of our 2 by 2 determinants we have done above. I'm sure you remember. How do you find determinant of the matrix A? As you can see, product of leading diagonal minus product of other diagonal. Exactly, you multiply across, right side is called the leading diagonal, left multiplication is called the other diagonal. Let's multiply. So determinant of A equal to AD minus CB. Now let's consider the Cramer's rule for 2 by 2 matrix. Given a system of equation, given a linear system, or the A values are called the column X columns, and we have the constant column. The B values are called the Y column. Now let's assign names for each matrix. Now the D, made up of A1, B1, A1, B1, A2, B2, is called, that matrix is called original matrix. Determinant of original matrix. Then determinant of X is given. That is what we call the X matrix. Then we also have the Y matrix. So these are called coefficient matrix. So let's continue with our Cramer's rule for 2 by 2 matrix. To solve for X, let's consider that to solve for X, we should have the determinant of X according to the Cramer's rule over original determinant. So that has been illustrated in the matrix given. To solve for Y, we are going to have Y equal to determinant of Y over original determinant. That's exactly what we have. Now let's solve this example. First step, we extract coefficient. So that's the coefficient we have over there. That is 2 minus 3 minus 1, 2. That is what we have. Second step, we calculate determinant of original matrix. That will be product of leading minus product of other diagonal. So 2 times 2 minus -1 times -3. Our final answer will result. Here we are. We continue with our Cramer's rule for 2 by 2 matrix. Now solving for X. We replace the first column of the coefficient matrix with the constant matrix. Very good. As we can see, the first column has been replaced. That is 2 -1 has been replaced. We now have the constant column to be 12, 9. However, the -2, -3, 2 for the other column has been maintained. Very good. We then calculate the determinant of new matrix and divide by original determinant. That is, we calculate the determinant of X and divide by the original determinant. Okay, that is the determinant of X. So that's the determinant of X when we calculate gives us 51 over the original determinant. We got 1. When we divide gives us 51. Very good. We are now solving for Y. So doing that, we replace the second column of the coefficient matrix with the constant matrix. As we can see, the first column has been maintained and the second column has been replaced. That is -3, 2 has been replaced with 12, 9, which is supposed to be our constant column. Very good. We then calculate the determinant of this new matrix, 2, 12 minus 1, 9, and divide by original determinant, which is 1. And so when we calculate this new matrix, That is what we have. That is 9 times 2 minus negative 1 times 12, which should give us 30. And the 30 divided by the original determinant, which is 1, giving us y to be 30. Now let's solve the last example. And in the last example, we are solving the system 2x equal to 16 and x plus y equal to 6. In doing so, we find the determinant of the original matrix denoted by D, and so we have 2 0 1 1. As you can see, equation 1 has no term in y, and so the second, it means that y has coefficient of 0. That's why we have 2 0 1 1. So we multiply across to find our determinant. So product of leading diagonal minus product of the other diagonal. So the product of the leading diagonal is 2 times 1, which is 2, minus the product of the other diagonal, which is 1 times 0, which is 0. So our final answer is 2. Thank you. Now we're finding determinant of x. By doing so, we replace the first column, is a column for x, with the constant column. So we have 16, 6 for the first column, while the other column has been maintained, 0 1. And so we multiply the leading diagonal, which is 16 times 1. Then we multiply the other diagonal, which is 6 times 0. And when we subtract, we have 16. So to look up for our x, we have determinant of x, which is 16, over original determinant, which is 2. When we divide, we have 8. Now to get our y, we have to look for determinant of y, which is 2 16 1 6. The second column has been replaced with the constant column. We now multiply products and find the product of the leading diagonal, which is 6 times 2, 12, minus the product of other diagonal, which is 1 times 16. So when we subtract our result, we get negative 4. Now to get our y, we divide the determinant of y, which is negative 4, over the original determinant, which is 2. When we divide, our answer for y is negative 2. Thank you very much. Don't forget to subscribe to my channel. Bye.